So yeah, welcome to the May 9th meeting of the Resource Management Work Group. I assume many of us are fatigued from discussing resource management topics all last week. But there are two items on the agenda today. One is a recap on what we discussed and maybe some discussion on next steps. And then we have a second item on the agenda to do a more detailed dive on the container device interface, which I think will dovetail a little bit into some of the topics we discussed last week as well. So with that, Connor, since you so happily volunteered or was asked to give the recap, why don't you go ahead?
Sure. So these are notes that that Derek took, basically condensed from the raw notes. It looks like that David Eshpol graciously wrote for us during last week. So the summary, we had 20-some people from a diverse group of companies, and there were a few work streams that were decided out of the 3 days. I think we came down to looks like 5 are broken down here. So the first one was support for resource classes, which is, I'm not sure if this is repeat for a number of you who were on the last meeting, but a level of indirection between what's in the pod spec and what is in the node capacity to allow for concrete resources to be aggregated into slightly more abstract things that end up in the user pod spec. And resource class is mentioned in a few of the other work streams, so this may be at least a soft dependency on a number of the other items that we have here. There are links to the detailed, I guess, what design we have is in those docs. Probably more work needed on all of these. Okay, item 2 was the extensible device support. And so this is, I think, just remembering back, NVIDIA agreed to be the guinea pig to implement a device plugin and also help out with the implementation of the delegation side on the kubelet. But the main idea here was that you would have a finely shaped API that's intended for an external component to advertise some device resources. And part of that information includes the topology subgraph, which the kubelet would add to its local node hardware locality information and use that in device assignment decisions. And it would also be responsible for initializing, tearing down, and health checking those devices that are consumed by user containers. I think there's a bit of design left to do on this one. I'm not sure exactly.
I would basically describe that's.
Feel free to jump in.
Yeah, I would say for this one, the high level themes were identified, and so I think the document that Vish and myself wrote up that I think is linked there builds a lot on a lot of the items that were presented in the original CDI or container device interface proposal, but adds some additional stuff that was not there. And so basically we need someone to go and take the next step and build a proposal that kind of blends the two. But yeah, right now, we don't have the detailed framework in mind for how the kubelet will trust individual device aggregators and stuff like that. So it's more like what are the core exit points we needed.
So I plan on spending some time here in the 1.8 cycle, at least to come up with a basic design idea on how we can implement such an interface. But needless to say, if someone in the community wants to go ahead and start working on it right away, feel free to do so. But the thing to keep out in mind, which probably has already been told here, is that the resource class APIs are probably a prerequisite for anything you want to do with devices. So that's probably going to have a higher priority relative to extended device support. So the existing NVIDIA integration might continue to function as it is and might not meet everyone's use cases, but even for that integration, we need like better APIs.
Yep, so Connor covered that part. But yeah, definitely resource classes are a prereq to extensible devices.
It seems like if somebody wanted to prototype, at least they could fake the resource classes with OIRs just to get something working, and then transition onto resource classes as soon as they become available. But that probably wouldn't go upstream.
Sure, that's fine.
Okay. So the third item here is enhancements in how the kubelet by default treats CPU resources. And I think the concrete goals we had here was to achieve good performance, or at least more predictable performance, when compared with VM-based orchestration systems. That was what Derek described as disappointing bake-off results when he was asked to compare VM-based containerization versus the CFS CPU sharing that is implemented by default in kubelet. And so the idea is to try to reduce the process scheduler latency by giving out exclusive cores to some guaranteed pods based on how the resources are requested. And there are two strategies that were proposed. One is called the dynamic strategy, which would be based on feedback from the perf event for the pod, and using that to do something smart with CPU sets. And then the static strategy would be, as soon as a pod that needs an exclusive core lands, would be to shrink the shareable pool to make a hole for that container, and then you would have a process that has exclusive access to that core for its lifetime. Yeah, was there anything else that we wanted to mention about this item, or does that pretty much cover it?
I think we basically want to explore those two strategies first, and before seeing where they're not sufficient, right? And it might be that there's a third or some other pluggable strategy required in the future that we can evaluate down the line. But I think that covered it pretty well. The only thing I would just add is like the dynamic strategy will be the default most likely. And so we need some people to prototype this before getting a more informed proposal out. So I know, at least at Red Hat here, Seth on the call is going to start to prototype something. I know some members of the community from Intel have expressed an interest as well. So it'd be good if people are interested in particular items, if they could speak up, and we can ensure we collaborate to build a good outcome for all. But yeah.
Yeah, that would be great. I know some of the members of our group started just by seeing what they could do in terms of refactoring the external isolator work to be the kind of internal delegate that we talked about during the meeting.
Yep.
To change it into more of just a CPU manager interface inside the container manager package.
Yeah, I don't remember, Seth, how much you've had time to look at this since last week. If you want to give an update on where you think the world lands.
Yes, I mean, I'm also looking in the container manager, and I mean, the CPU set C group is kind of strange. It's got a CPU underscore inclusive property, but we don't want to set that because that's going to cause nightmare scenarios with races and things like that. Basically, what it does is you define the CPU set for the CPU set.CPUs for your CPU set, And if you set exclusive, well, one, if any CPUs in your CPU set are included in a sibling CPU set, that fails. If it's not, then your set exclusive equals it succeeds, and then those cores can't be assigned to CPU set and sibling CPU sets. So yeah, it's kind of complicated, but I think what we want to do is basically make cores implicitly exclusive by just removing them from all the sibling sets and not setting CPU underscore exclusive. But yeah, it's basically what that means is that whenever a guaranteed pod lands on the node, you're going to have to go through and touch every CPU set, like at the clause, pod, and container level to reserve that core for the guaranteed pod. So it's tricky.
And I think the other thing to call it is like the code paths, I think, for either strategy should not be like diametrically different. Like they have very similar problems. Like they both need to schedule a CPU. They both need to release a CPU. They both need to potentially know how fragmented they are. So I think the hope is that for either code path, though, like we can get a base primitive that works from a code standpoint that things don't look fragmented, right? So
yes, I mean, it can all be abstracted away.
It's just code.
Like a shared hierarchical pool abstraction or something that they both manage. But
yeah.
Anyway, we don't have to design it here, but yeah. Seth, if you wanted to collaborate on the same piece of code, we'd be happy to try to figure that out.
Okay, yeah. As soon as I have code, I'm just writing a try to get an end-to-end prototype working such that I can make a meaningful proposal. But as soon as I have code that is meaningful, I can share that.
Okay. Same on our end. We'll just stay in touch.
Okay.
Cool. Okay, so the next item was, huge pages will become first class, and will support both modes of consuming huge pages, either directly using mmap or shimget, or via the huge TLBFS. There was some work already for a huge pages backed memory volume driver. So yeah, I guess for this one, it may be a matter of, how much can be parallelized. Can we set up the new resource and the setting up of the C group limits in the kubelet in parallel with the volume plugin, or does one have to block the other?
So the one thing
this seems like the best defined one out of all of them in terms of work that could immediately start.
Yeah, I think the thing we need to iron out on this is, I think in the various prototypes that are out there, let me think about how to phrase this. If we choose to map huge pages via resource classes and have an indirection where like you just say this is the size of a huge page I want, independent of the actual page size, but that's awkward to say. But if you just say I want a gig of huge pages and you don't care if it's 2 megabyte or some other alternate architecture size, then like you might want to use the resource class model that Vish discussed. And so maybe resource classes would come first. But if we don't feel like that's a strong requirement, then yeah, this one feels pretty standalone.
So the idea with that was that you can specify minimum requirements and not worry about whether the application requirements are met by static partitioning.
I missed that, Vish, I'm sorry.
So I was saying that like having resource classes in the mix would basically mean that you can have portable API specifications and you don't have to statically provision your cluster to meet your app requirements.
I'm sorry that I'm unable to connect that to huge pages stuff. Are you saying like I could either make my resource class for memory be backed by normal memory or not normal memory?
No, I'm saying that like if you ask for huge pages that are of like 5 gigs, and if that's part of your resource name, then you're sort of tied to a specific deployment, right?
Oh, yeah.
Yeah,
Yeah, either way, I agree with that. So I guess we need to, that's probably the one edge case on the huge base stuff. And I think the other edge case was just ensuring that memory accounting is working as we expected. So I think we have to verify that the memcg group is not double counting huge page consumption outside of huge TLB. Yeah, generally we should be close to being able to get a final proposal on this stuff soon.
Cool. Okay, so second to last one here is NUMA. So the intention is for the kubelet to understand the node topology. So it'll do some sort of, I guess we talked about an initial round of introspection into at least the CPU socket topology. And then when device plugins advertise their own resources, those graphs would be appended to the known topology of the node, and they would all be considered when making local resource allocation decisions on the kubelet side. So I guess the one hard design constraint that we decided during the meeting was that the node topology will not be advertised to the scheduler. So the scheduler will just deal with counting resources, and the kubelet will be concerned with mapping the allocated number of resources to concrete resources once the pod is assigned to the node.
Yeah, so I don't know, Vish, if you want to add more color here to this, but I think generally speaking, in order to go deeper on NUMA, we need to get basically the graph modeled in the kubelet. So like, there's a lot of prereqs we need to land before then, and I think we'll learn some things along the way around like how we should treat relative weights or which resources we should give better weights. And I wouldn't be surprised if in a few months' time we have a bunch of like scoring policies that might be tied to clause or something different to say like what's a minimal acceptable score for this thing to meet its constraints. But I think we would all generally agree that the qubit will do something. It'll be NUMA aware, and how advanced our policies get are determined.
Yeah, I think like I need like a more detailed proposal on NUMA.
Yeah, it's not easy. So yeah, let's wait until like 1.9. That's okay with you, Derek? Yeah, I completely agree. I mean, I would want to get resource classes, devices, and CPU figured out before trying to wrap it well on it. Would you agree with that, Vish?
Yeah.
Yeah, okay, yeah. But I think generally speaking, it's helpful for people to know that the kubelet sees NUMA on the horizon and it needs to be somewhat intelligent about it in a future time.
Okay, and then the last topic that we talked about was performance measurements. And the main idea is to provide some way that we could witness performance regressions that happen specifically with node local policies, and also to compare proposed isolation strategies against each other in different situations, hopefully reflecting commonly deployed workloads in the cloud. So there's one example linked here, which is a project that happened at Intel, and it's mainly about allowing the user to program experiments, and each experiment consists of a bunch of different configuration values that get unfolded into a matrix, and then what you end up with is a big graph of sensitivity profiles for specifically a high priority workload versus some co-located aggressors. So you end up with a graph like this. And the main point was not to push this project specifically as a solution, but just use it as inspiration for what kind of data we might want when we are making decisions about default kubelet policies. Because I know a bunch of the people on the call are have real world experience with being fooled by intuition in the space. It's easy to make a mistake and do something that doesn't behave as you expected.
So one thing I wonder on this is like how we can take like these performance measurement data and then like make something more intelligent so that we get like affinity and anti-affinity scheduling rules assigned like intelligibly. So I don't know how you thought about that much, Connor, but like generally speaking, I know we spent a lot of time talking about like initial resources as potentially a thing in the Cube project where like based on historical usage, you can see what your default resource assignment should be. But I think it'd be good to understand like how we as a project can get more intelligent on like understanding that this pod as like an aggressor to another pod, which I kind of viewed that graph as showing, right?
Yeah, I think the one paper that comes to mind is Quasar from Stanford. Christina Delimitriou, I think was her name, and Christos Kozirakis. But anyway, it was all about offline profiling and right sizing and doing co-location to reduce basically to reduce the job completion times for a big set of batch tasks. But I would think that would be like a V2 or 3 or 4 after
No, I understand. I'm more wondering like with tools like Swan and I get the data, like how can I use the existing primitives today to like in our scheduler to respond to that data, right? Like and I'm wondering if like there are like particular affinity rules or particular label patterns we can apply to pods to make things easier to consume. So like if you know that you're I got to read through your stuff more a little bit more, but I feel like we might get a large swell of like decent data, and it'd be good if we could have just like it's unclear to me that we need new code to like respond to the performance measurement, as like how to know where it's safe to schedule certain things, how to use affinity or anti-affinity to get your desired outcomes.
Maybe we can defer to the Google folks on the line and see if they have some existing work that they could talk about.
No.
Yeah. Okay.
Okay.
I just know when I asked you about the priority stuff, I learned that you guys had like 28,000 different priorities. So I thought maybe you might have some secret performance measurement stuff too. Anyway. So anyway, thanks for giving the summary, Connor. And for the folks who are unable to attend, are people okay with what was described thus far? And I recommend people to read through. But is there any feedback where you're like desperately unhappy about any of the things that's been presented here and you want to raise your concern? Okay.
Are you speaking? We don't hear you.
So it could be David Oppenheimer because he's the only one that's not unmuted. And
Yeah, I heard something. I thought he was speaking, but maybe he wasn't.
Okay. He's muted, so I guess not.
Sorry,
But,
what was the question?
No,
You weren't-
sorry, we heard something, and then your name showed up on the screen, so I thought maybe you were speaking, and your mic was not working well. But anyways, looks like you were not.
Okay. So assuming there isn't any immediate things that get people too upset, we can move on to the second topic on the agenda. So Dennis, I don't know if you're there. I think you're there. I think you wanted to give a rundown on your thoughts behind the container device interface proposal, and maybe you can walk us through that now, and then we can give you some of our perspective back for items that we might have touched on at the face-to-face.
Yes, I'm here. Can you hear me?
Yep.
Fine. I think, yeah, you basically, in the summary, already mentioned that you are going to implement this part using a gRPC API, and NVIDIA is going to do it?
So I don't think the mechanism or the transport is defined. It's more like what are the use case requirements? I think we kind of nailed down the set of use cases we were looking for, and then what are the high level like design goals we need to achieve? I think we nailed down, but the actual mechanics I think are still to be determined.
Okay.
I think the only major thing differentiated from your proposal was, I'm sorry if it's a bit delayed since I read it, was it worked at the pod scope and was like not opaque to the kubelet.
Yeah, and it's also not a binary in that like it's a long running process.
Yeah. So yeah, well, I just tried to mimic CNI, the container network interface, because I thought, well, it works already, and it has some elements that are similar. So I, yeah, just did that for device discovery. I implemented that in the proposal after your suggestions, and it also has, well, device discovery, allocation, and deallocation, and communication. In this proposal, in this version of the proposal, happens the commands go through environment variables, while the output goes through JSON, through standard out.
Just to let you know, this is Dan Williams from SIG Network and also a CNI maintainer. We're sort of moving away from environment variables for some of the stuff because we thought they weren't quite as flexible. And so instead of environment variables, we're moving to push that information through the standard input JSON configuration instead.
That was exactly my idea. Yeah, also the configuration file, I would also include it in the standard input together with the commands because I think they are, well, somehow connected. I also wrote that in a comment to the pull request yesterday, I think. Yeah, I think the main difference between the what you worked out at the face-to-face and what I proposed is that this is a binary and the other one is the long-running process. I don't think it makes much of a difference for me, at least for our use cases. I don't have much.
One thing I'd be curious about is there were particular devices that you were looking to support that might have unique constraints that we didn't discuss. So at the face-to-face, I feel like we spent a lot of time discussing GPUs, and then there was a host of challenges around GPUs that might be unique, but
actually, we did talk about the scenario where, like, as a vendor, you don't really care about giving a plugin, but then you just want to write binaries. And if I recall correctly, the general agreement then was that the container that's going to be the plugin can include additional binaries, and then you can have one more level of indirection than that. Like, you're basically having a proxy that proxies from any API that you have that could be an executable, for example, and then it proxies over to the gRPC endpoints that Kubernetes would understand. But at the end of the day, the general mechanism is that, like, you have character devices. I mean, this is all like not yet fully defined, but then you have character devices or block devices, and you may have topology associated with that, and then Hybrid is going to orchestrate access to that.
Yeah, but I guess the other things that I was thinking about, Vish, and I agree with what you said there, was that I feel like we spent a lot of time discussing how to get kernel drivers as well as user space drivers that might be associated to your device. And then we spent a fair amount of time discussing, like, in the allocate step, if that was going to be used. And so I feel like we got a lot of pushback on the GPU side that they did not want to use the allocate step as a way of exposing container. I wanted to do that with run C hooks, but I wasn't sure, like, Dennis, if there were particular devices you were looking at that might have similar challenges that might help us maybe better understand the constraint space better. So, like, are there equivalent, like, kernel drivers or user space driver issues that you had thought through with any of the devices that you were looking to integrate with?
Well, our use case is also GPUs, but we also looked at AMD GPUs, which don't have the user space constraints, because the kernel driver and the user space is basically decoupled. So that's probably a bit easier. But apart from that, there is no difference. Our use case is for visualization. So yeah, that's why I also included TTY as another example, because, well, to get an X server running, you sometimes need a TTY.
Okay. So I guess trying to think about how to proceed here. Are you interested in pushing the device proposal forward further? Like, are you agreeable to maybe looking at some of the documents that we've put out and then digesting those and then potentially iterating on your existing proposal? And maybe we could use that as the PR to rally against? Or I guess what I'm trying to figure out is, like, how long-term engaged are you looking to be in the project to push the feature forward?
Well, I already read most of the documents from the face-to-face meeting.
Okay.
And yeah, if that's still an option for you to propose to follow this proposal, sure, I can go through that and iterate with you. But I don't think it makes much sense to go two different routes. That's why I would like to coordinate with you on, like, one proposal.
Yeah, that's what I was trying to think. If we could get an alternative proposal written that, if you had time to explore, that'd be great. Like, a lot of things are not defined, right? I think the mechanics between how Kubelet does device discovery local to any daemon set pods that are running there needs a lot of detail, and I think I think one of the things that came up there was we wanted the kubelet to be able to do a list and a watch on individual device plugin providers rather than polling, so that we can respond more quickly when we know a device failed. And so I think I'm just, if this is a topic that you're particularly interested in, you want to evolve your proposal to take account of the scenarios that we discussed and assume a world where it's more native to the kubelet, I would be happy if folks in the community wanted to do that. So yeah.
Sure.
Okay.
Sure, that would be interesting to me. I would like to do that, but yeah, who should I coordinate with? There are multiple people working on this or interested in this, so.
Yeah, so basically we need someone to both prototype to inform a proposal and write the proposal. I think from a coordination standpoint, if we assume that the concept of a resource class will exist, then, like, I assume Vish, myself, and maybe Renaud from NVIDIA are probably the ones to coordinate with. But, like, I know personally myself, I won't have cycles to work on a proposal for the next few weeks, and I assume Vish is in a similar boat. So like, I'm just more wondering if you have time, if you want to go and take the baton to drive the ball forward a little further.
Yeah,
Okay, so
realistically speaking, I think like having or trying to come up with some alpha API in the 1.8 time frame might be more realistic. Like,
Yeah,
I
I'm
want
not.
to set the expectations clearly.
Yeah, so I'm not expecting anything in Cube 1.7, right? I think the feature concepts has been passed on that. I'm more just wanting to, if people have time and cycles to dedicate and think on this, and they understand where we as the broader group felt like any proposal should go, then like I don't want to discourage people from iterating on that proposal.
Definitely.
Yeah.
It's just that like sometimes people get frustrated that they're not receiving any feedback or they're not making any progress. That's the reason why I wanted to like set the expectations straight that if like Dennis goes and spends a whole bunch of time and then nothing really happens or like it doesn't get merged into a stream in 1.8, I don't want him to feel bad. That was the intention.
Yeah.
could you please repeat the last part? It was a bit mixed up.
Sorry, so I was just saying that like oftentimes what happens is like there's amazing work happening, but they're all happening together and they're not part of the roadmap. And so oftentimes like those amazing patches, proposals, designs, they don't get the right kind of attention. So I want to avoid that with all this work, and that's why I was trying to set the expectations straight, and that it's probably unrealistic to get a working implementation, even if it's alpha, in the next release. So I was just suggesting that like having a fully scoped out prototype and a proposal might be a more realistic goal for the next release.
Mm-hmm. Yeah, my time frame would be like half a year, maybe.
That's fair. I think that's more tractable than having a few implementations against that API would be amazing.
Mm-hmm. So I will coordinate with Reno.
I'm not sure. I don't know. I don't think Rena was in the call, and he said that he was an intern. So I don't know how long he would be at NVIDIA.
Okay.
If Rena is not responding, then I can probably help you out because this is something that I intend to focus on. But I don't know if I'll be actually contributing to it.
Okay.
Yeah, and me as well, Dennis. So it's Derek. But yeah, so that, I think we've gone through the 2 agenda items here. Any other topics that people want to raise for today?
So at the end of the face-to-face, we put some kind of ringleaders onto the topics just to get a roadmap together. I was wondering if we wanted to have like a consistent format for what the roadmap should look like for each one, or if there are some examples that we should follow.
So when you mean ringleaders, what was that a part of the?
Yeah, I mean, basically we listed all the 6 items, the 6 major items that we discussed, and then we tried to like identify some basic shepherds or like high-level owners who would then draft some form of a roadmap, and then we wanted to bring all those features together and then like figure out an overall roadmap that might span a year or something, because we don't want to do all of that together, and so we were wondering like if we can merge all that together and then like have a clear long-term roadmap, like even if the long-term is just for a year. And begin that process, we try to identify some owners for each of those major topics. I guess like each owner is going to try to come up with some form of a detailed work plan, even though it need not be accurate, but it's supposed to give some idea on like how long that effort is going to take. And depending on that, we can stagger or we can do things in parallel and so on.
I guess what I'm missing is where was that done?
It should be in the meeting notes doc at the end.
Yeah, I don't see that.
There's actually a link from, I think, one of the first lines. It says topics and contacts. It's a separate doc that's only 1 page with each item and the contact listed. I just dropped it in the chat too.
Okay. So given that yeah, given that folks at Red Hat weren't there at that point, I want to go back and augment that. And I think let me take a moment to digest this, but as I noted there, we have more staffing available to work in these spaces, and so it might not just be the same set of names.
Yeah, so those are just placeholders for now, because we just thought that we could make you an owner of everything, so we just added your name.
Okay.
That's just a starting point. And
yeah,
just
so
like help make progress.
So looking at this list, the only thing I would add is like what we discussed here, which was we're very motivated to do something in the CPU space in the near to midterm. And so Seth has been tasked with that. And so as long as Seth and Connor are communicating, I'm happy. And then I will go through the rest of the list afterwards to give more detail. Like on the context side for resource classes, Vish, that's really like a two-part problem. It's like a scheduler problem and a node problem. And so I wasn't sure like who we assumed was maybe going to go and prototype the concept to ensure that like even basic counting can work. And there are potentially people on my team that I could sign up to do that, but that would just be verifying that the thing will actually work and not necessarily the final thing.
Sorry, which feature? Which feature are you talking about?
So this would be the resource class feature. So I think one of the things we weren't sure about with resource classes is like if the scheduler will be able to actually properly count the resources consumed. And like, so David, just for context, like I have a couple of people on my team that largely are dedicated working on scheduling. So that would be like Avesh and some other folks. And so like, I was just trying to think through like for folks that are more active in the SIG scheduling side, having them do an initial prototype just to validate the concept might be useful.
Yeah, so there's also the interaction with Coda and like defaulting and so forth. So I think
yeah, so that's a whole separate topic. For Quota, I think I noted that I was a little concerned that we haven't a lot of community participation in Quota, aside from some folks here at Red Hat, really. So, but I thought that was really tangential from the resource class stuff.
Yeah, I guess if we get the resource accounting right, it can probably cover the Coda accounting as well.
I mean, all Quota counts is pods, right? So as long as you count the thing, we're not going to count. Maybe there's an assumption on my side that Quota will not count the concrete resources, but the resource names identified in the resource class itself.
Yeah, so that's the part that I want to like fully flesh out.
Yeah, this is
and then I also want to like flesh out a little bit more how limit ranges would work, because you don't want to like keep adding new fields in the API for every single resource that's being added. And that sort of ties into pod presets too.
Okay.
Validation is important.
So I will go and review this list and throw other related contexts. But there's more people than just those that are present on this call that I can contribute to the effort.
Okay, that's awesome. Maybe we can sync up offline, Derek, and then find out how we can have this work.
All right, thanks.
So are we done?
I think we're done.
Okay, thank you guys. Bye.
Thank you. Talk to you later.
Bye.